Hello and good morning. I'd like to start by acknowledging that I live and work within the traditional territories of Kwanlin Dun First Nation and the Taunton Council. For those of you who I haven't met yet, I'm Brianne Warner, the Executive Director for the Yukon Chamber of Mines. Welcome to our session 5 of our Geoscience speaker series. The difficult decision to cancel this year's Geoscience had us pivot to this online speaker series, which we're offering free of charge. Special thanks to our generous sponsors. It is important to our chamber to ensure we continue to offer opportunities for industry to network and communicate their achievements and attract investments to our territory. Whether it be in person or over Zoom in the coming months, we will look forward to offering this type of series. Please take the time to check out our online silent auction put on by Northern Safety Network Yukon, the Yukon Chamber of Mines, Yukon Read Society to raise money for the Yukon Imagination Library and the Yukon Mines Legacy Foundation. The auction will end on Thursday, January 27th at 12 p.m. Yukon time, and the link will be posted in the chat. If you have any technical questions, please contact events@csrmanagement.ca. At the end of the session, we will offer a Q&A with our speakers. Please type your questions into the chat, and our moderator today, Patrick Sack, will ensure that they are answered. These sessions will be recorded and posted on yukongeoscience.ca. Again, thank you to our partners, BMC Minerals, Yukon Government, and our gold sponsors, Air North, Yukon's airline, Archer Cathro, Alcan Air, Newmont, Invest Yukon, Summit Camps, NVD, Cobalt Construction, Kelly Construction, Hummingbird Mobile Health. With that, I will pass it on to Patrick Sack to introduce our very first speaker. Thank you.
Good morning, everyone. My name is Patrick Sack. I'm an economic geologist with the Yukon Geological Survey. We've got a nice lineup today, 5 talks, gold focused. 4 of them are going to be in the Selwyn Basin. And then the last talk, we're going to skip over to the Bennett Lake in Southern Yukon. As Brianne said, if there are questions during the talks, please type them into the chat. We will do a questions at the end of all 5 talks, not between talks. So type them in and I'll make sure that they get asked during the final Q&A. So without further ado, we're going to start with Tara Christie from Banyan Gold, and she's going to give us some exploration highlights from the Ormac property.
Thanks, Patrick. Great to see everyone this morning. Thanks for joining us. I'm going to talk to you mostly today about our exploration on the Ormac project. You know, this image on the front of our presentation really puts it in context where we are. This is the road from Mayo up to Alexco's Keno Hill here to the north. This is the road that comes out, the McQuestion Road, South McQuestion, that comes out to Victoria Gold and their substation right here. We're focused on our airstrip deposit, which is right here, our power line deposit, which is right here, and then Oryx Hill, which is this low rolling hill. And this is primarily a geological focused presentation. I have to give credit to James Tom, our exploration manager, who's our team's up in the field today, getting drills warmed up and starting our season. So we were a little uncertain about whether James would have internet suitable to give this presentation. So he does deserve the credit. And I also acknowledge that our Ormac and our Nitra properties are both within the traditional territory of the Nacho-Nyak-Dun First Nation, who we work very closely with. So, you know, actually all 3 of our projects are in the Selwyn Basin. Our Highland project to the south near Watson Lake also is very similar, structurally controlled sediment hosted gold deposit. Our Ormac project up here, this is where we put out the resource in early 2020 with that 774,000 ounces at airstrip and the power line deposit 129,000 ounces at 0.61. We're on the cusp of updating that resource here in Q2 2022 with the work that we're doing. And really, I want to focus on some of the technical work that we're doing here, as well as we think we have another deposit area, Oryx Hill, where we'll have another resource. It's a really busy area. We've got lots of great neighbors, including Alianza, Victoria Gold's Eagle Gold Mine, Alexco and Metallic and Mayo Lake. It's a great place to be working and really facilitated by that infrastructure. Why is everyone there? Well, there's two big mineralized systems, which really have impacted the area, the intrusion-related systems of Victoria Gold and Alexco, or Victoria Gold and Banyan's Ormac, and then the Keno Hill style, slightly younger, Belkino and Birmingham. We also see some of it Ormac, and I'll show you some photographs of that. That's what Alianza's really looking for as well. So we know there's lots of structure, there's lots of the properties of the rocks here are suitable for skarn and intrusion-related mineralization. In 2020, Alexco really contributed to the geological knowledge in this area with their new update of their map, and it's up here on the top compared to the original map down here, or the known geological survey map by Murphy and Roots. And you can see where we're working, really there's not a whole lot of information, there's a lack of exposure, and so there's been interpretations on where these various contexts and faults are. One of the main things that happened was that the change in the nomenclature by changing the Keno Hill quartzite into the basal quartzite member and the Sourdough Hill member. To the Sourdough Hill member, they added some of the Highland group schists and then moved the Robert Service fault slightly to the south. So, we're working in this area of evolving nomenclature, and we think that our observations, particularly since we have so much drilling right around airstrip and power line, which is right around where these contacts are, as well as where the faults are. So, the airstrip drilling here really gives us some control over where the contact between the upper quartzite and the graphic schists should be located and where it can be put on the map. And then the power line drilling to the south, there's very little difference between the Sourdough member schists and the Highland group Usizu formation schists. But we do know that the Robert Service fault was put between here. We think it should be pushed further to south, and one of the reasons that we think that is that we do have a greenstone sill that we see, which if it's of Triassic age would push that fault to the south. And in that sill, it has relic phaneritic texture of metadiabase and sort of on the meter scale. So lots of information to come from us as we continue to be able to provide some drilling information in this area that has very little exposure. So here's just the airstrip geology. This is the Sourdough Hill member, typical section between the undifferentiated graphic siliceous schist with locally limey layers. And these limey layers are so important. They're what hosting our airstrip mineralization, and then the bulk of that resource. And then, we transition into the more siliceous cyst. The blue unit here is all that unit. And then the upper quartzite is in red here. And, this is more the upper quartzite here. You can see the layers of these quartz veins, which are also hosting mineralization. And then, at the top here, we see this late Cretaceous dike, and this dike crosses all the units so that it is in contact with the upper quartzite. So, I think this will help us understand what's going on in this area. And then here, this is the section at the power line, potentially the Sourdough Hill member. And here we see the greenstone sill. And in this case, it's 15 meters thick, so pretty thick. You can see relic phaneritic texture, likely hornblende that's been altered to chlorite. And this unit's always magnetic, calcareous. It can be massive, but it can also be banded, and it has a distinct mafic geochemical signature, that nickel, chromium, magnesium, vanadium. So, 2020 was really an important year for us. We put out that initial resource in those two pits, and the orange outline is the outline of the pit. The black dots are the ones that went into the resource, and the blue dots were what we drilled in 2020 subsequent to the resource. And you can see, with the drilling in 2020, we've expanded the mineralized envelope to the west, down dip and to the east, as well as to the south power line. And then, we started to get some information on Oryx Hill, again, seeing these shallow dipping sheeted veins at power line and at Oryx Hill. And then, what really started to make us think that this was a bigger system was that line of holes to the south, where we got, a couple sections here just highlighting that, these are quite wide intercepts of significant grade. And we started to be able to put together the story. The power line, here you can see an example of those quartz veins with that primarily host the gold. This hole was drilled in 2020. We had 12.5 meters of 2.34, so pretty good grade. And again, these veins are discordant to foliation. These sheeted veins, and they can typically contain arsenopyrite, scheelite, sulfosites, and tellurides. Some more pictures. Here is a great hole, 41 meters of 1.4 right from surface, from power line. And you can see the sheeted veins, the density of sheeted veins is what's carrying the grade. And then we have some instances where we get these very high grade veins. Here was 95.4 grams over 0.3 meters. Again, quartz arsenopyrite vein. Oryx Hill, we have a significant weathered surface preserve, so almost 40 meters of weathering in some areas. This hole was 25 meters or 20 meters of 0.91 right from the surface. And again, these shallow dipping, flat lying quartz veins discordant to the foliation. And then just looking a little deeper at the unweathered in power line, here is 7.8 meters of 0.72, and you can really see the veins here. So 2021, fast forward, exciting year with 30,000 meters drilled. We focused 122 of those on power line, just 17 up on Oryx Hill. And of course, the oriented core that we did is giving us lots of useful information to determine the orientation of these gold-bearing quartz veins, as well as we develop the 3D models and the resource update that we're currently working on. Power line, we're also seeing this very strong east-west trend, and this is a section right through across the power line and the highway right here, and this is the substation. Always the best gold's right under the substation. You can see the pink dots are all the holes that we still have outstanding, and we actually still have assays from 63 holes from our last year's program outstanding. So lots of results still to come. But what I wanted to show in this section was really that we're seeing some consistent higher grade that we can track from hole to hole. And these holes are all dipping to the north at negative 60 degrees. So they look vertical, but they're actually dipping to the north. So, what this is telling us is that we can see correlation between holes in these layers. At depth, we're seeing some of these smaller layers, which we can correlate as well. But, this really tells us this is still open. It's open to the east and the west, and potentially showing us, that there's more of this exciting grades. And these are primarily 100-meter step-out holes. So most of our grid is 100-meter step-out holes, which really lets us explore a large area very rapidly. We did start to do some infill drilling, which you've probably seen on some of these slides, right around this one area in power line. We really wanted to understand the grade continuity and how these sheeted veins are correlated. So that will also give us some great information going into 2022 here. So, we have a little summary here of our oriented core to date. And, kind of the big highlights are that the discordant veins, both the dip and the dip direction of them at Oryx Hill and power line are very similar, pretty consistent, these sheeted veins. The foliation, however, which predated the veins, we are seeing about a 20-degree difference. So there is some folding or some change in orientation of the foliation as we head over to Oryx Hill. And that might give us some more information on what's going on, as well as give us some targeting information for as we continue to expand the deposit here. So, these systems, pretty typical, this gold, bismuth, tellurium. I think you'll see that on other intrusion-related deposits. We're seeing both stratigraphic and structural controls in our 3 deposit areas, airstrip, power line, and our target area, the Oryx Hill. We can see some subtle differences here in the geochemistry. Oryx Hill, which is more structurally controlled, has a relationship with arsenic. Power line, we're seeing both structural and sediment controls. And then, our airstrip, where we're seeing this strong correlation with calcium. So more information as we continue to get results. We don't have all of our assay results to be able to update this database yet, but we're going to continue to do so to help us understand what's going on. Visible gold, this we're seeing lots of it in the holes. We're probably missing some, but the yellow dots here indicate all the holes where we did find visible gold and pretty significant quality. Some beautiful photographs of it. It's all very fine grained. And I'm going to show you some photos of it as we move forward. Oryx Hill, that's a very large target area. I showed you that in the original photograph. The mineralization there, we really focused on just a very small area targeted with our drilling, largely because there were existing roads into it, and we were able to drill it fairly easily. But we've got a 10-kilometer squared soil anomaly up there to follow up on, lots of historic RAB drill holes. So really, this is just a start for us at Oryx Hill. And you saw in some of the previous images that we do have drill holes, which show that mineralization does seem to go from power line all the way up to Oryx Hill. So here's just some photographs of seeing the visible gold in core. Here's the visible gold, and if you were to zoom in, it'd be here. And here's another photo of some visible gold, and you'd have to zoom in here to see it. So our geologists are developing an eye for finding very fine visible gold. I did mention that we had Keno Hill style mineralization, and I was really hoping to be able to show you this core at our core shack, but hopefully we'll have core shacks coming up soon. This section was about 2.5 meters in the drill hole. It's probably about true width of around 1 meter, but we are seeing some of the influence of the Keno Hill veins cross-cutting some of our mineralization in the airstrip and the power line. So more to come on this, but exciting that we found some of it. And then just a quick image of the mineralization at airstrip, this purite pyrite quartz alteration. And again, some nice core I'm looking forward to showing you at airstrip, or at the next time we have an opportunity. Maybe that's in the tours in the summer. So, our program also, the part of the science is our metallurgy. We started this in 2020 with some dedicated holes. Because it's great that we're finding gold and we're starting to understand both the chemical and the structural controls on it, but we also need to make sure it's recoverable. We're using Forte Analytical to do all of our metallurgical work. They're the same company that's doing the work, grade control and work for Victoria Gold. And we were really pleased with the initial bottle rolls, and they're on pulps, 90% recoveries between the oxide and the sulfide. And you can see here the arsenopyrite crystal and the gold has intruded in fractures along with pyrrhotite. And we see it again down in this micrograph of there's the arsenopyrite crystal, and we've got the pyrrhotite and the gold occurring in it. So that's pretty encouraging for us, and that this gold is potentially heap leach recoverable and not refractory. We do have some column leaches ongoing, and we're continuing to do a database of bottle rolls, particularly on Powerline and Oryx Hill. So more information to come, but a really good start to the database of information that we'll have. So just a quick summary on where we're at. Our resource update is planned for Q2 of 2022. It will include the 2020 drilling and as much of the 2021 drilling as we get by the cutoff. So potentially that's up to 34,000 meters at Powerline and 6,000 meters at airstrip. Just under 6,000 meters to go into an initial resource update potentially at Oryx Hill. Our drill program started, our crews in the field, so thanks to them and to our contractors. We'll be working on further analysis of our structural, geochemical, and geophysical data, and talking to the Geological Survey about what we're seeing right around that map area, so that we can contribute to the next version of that map. And, as we're working on our 3D geological model for Powerline and Oryx Hill, we're going to continue to get additional information. Our down season's pretty short. We shut down our camp on December 20th and we're running again. So our geos don't get a whole lot of office time. James Tom is going to join us for the questions. We're a little uncertain about whether he was going to have decent internet to be able to give this presentation, but thanks to him for putting it together. And that metallurgical work's ongoing, and you can see lots of additional areas for us to expand. The east and the west at Powerline mineralization is looking strong, and Oryx Hill, there's just that huge area. So look for an exciting year for us as we get drilling here pretty early. I want to thank our team. We're a pretty small, lean and mean team. Beautiful view at our camp here with Mount Haldane in the background. So thank you to our suppliers, particularly Kalani Drilling, Mail Landing Fuels, Air North. We're using both SGS and BV. So looking forward to both of them increasing their times. And of course, Yukon Geological Survey for YCM has been so important to all the discoveries, and all of us in the geological community. Thank you for your efforts, and our field crew. And we, over our break, we lost one of our team members. So shout out to him. He's been with us since 2017, and we were very sad that he won't be joining us back for this season. And that's all I have to give for my presentation for today. Look forward to more information from us. Great year plan. Thank you very much.
Wow, what a start. Thanks, Tara. That sounds like a great year, and I can already have I have some questions for you, so I imagine you're going to get hit pretty hard in the question period. We're going to move on. Next talk will be same thing, Selwyn Basin again. We've got Scott Burdall from Snowline Gold is going to tell us about the mineralization they found this season on the Einerson and Rogue projects. Over to you, Scott.
Hey, Patrick, thank you. Let me just get my presentation loaded here.
That looks great, Scott.
Okay, perfect. Yeah, so we are Snowline Gold Corp. We are a new face, at least in a corporate sense, to the Yukon exploration scene. And we're very happy to be fresh off our first season. It's been a really successful year and a great ride so far. And before I go further, I'd just like to acknowledge that we're exploring in the traditional territory of the Notchunayakdun First Nation. Our flagship Rogue and Einerson projects are both within on the eastern extent of their traditional territory, out in the sort of eastern extent of the Selwyn Basin. I like to think that we're a forward-looking company, and we will be making forward-looking statements. So just bear that in mind. Yeah, a lot of well, uncertainty in this industry, as everybody knows, but that's part of the business. So we are a new company, but we're not a new endeavor. Many Yukon viewers will know that the company comes from my father's prospecting endeavors, which he dragged me into from a very early age. That's me in the bottom left there. And we've been exploring, well, you know, with my father's start, we've been at it for 30 years. And through that time, we've optioned and staked over 1% of the Yukon Territory's land area. A lot of that turned out to be moose pasture, but a lot of ideas hit home, and we now have the benefit of a lot of work that's been done on that ground, and that really forms the core of starting Snowline. You know, you get a lot of projects to the stage where you need a public company, you need a major or a junior to be able to put in that capital and take ideas to the next level when you've gathered all the evidence and found the drill targets. And so really Snowline is lucky to start at that stage. And I should also thank, you know, it's not just us. A lot of entrepreneurs, a lot of companies, and a lot of individual prospectors have done a lot on our portfolio, and a lot of great geologists out there too, as well as the Yukon Geological Survey. So yeah, we're indebted to a whole slew of people for helping to make this happen, and particularly the Carlos brothers, who have done, well, they did some great prospecting on both the discoveries that I'll talk about today. So out of those 30 years, we carved 7 projects, all of which we thought had the potential to host sort of 1,000,000-ounce plus gold deposits. We've sort of, well, we've very much explored off the beaten trend as much as we could. So, you know, the White Gold Rush, I basically never set foot in Dawson. We were out on the eastern side of the Selwyn Basin, as I mentioned, in the southwest Yukon and other places. So that can kind of make it tougher to sell properties, but it also makes it easier sometimes to stumble into some pretty interesting ground. And again, we've, with the other companies that have come in and worked on our projects and work that we've put in ourselves, we're fortunate to launch Snowline at, you know, at a very attractive stage as far as a company goes. We're drilling, and we're drilling targets that are really teed up for discovery. Now, this is nothing new to Yukon geologists. This was the story 10 years ago that, you know, the Yukon is, or the Selwyn Basin in particular, is quite analogous to the Great Basin in Nevada. They were formed off the same coast of Rodinia, passive margin sequences, very fertile for both lead and zinc deposits, but also gold and silver. And Attack Resources, of course, made a terrific discovery of well, Carlin style gold in the Yukon, which really changed the game up here, and that well, that boom sort of passed with 2012 and the rest of the industry. But I really think that they're just scratching the tip of the iceberg. I mean, attacks. They pulled out the 1.7 million ounce deposit at 4 grams, pretty nice number, and really that looks like the tip of the iceberg. They have a lot of projects or a lot of targets on their property, and we're finding that there's a lot of interesting stuff on ours as well. I think a bigger part of the story here is it's not just Carlin. I mean, you get too focused on one deposit type and you can miss a lot of what else is out there. And so what happens to a Carlin style fluid if it doesn't hit the right chemical and structural trap, but instead, it gets into a structural domain where it just loses all its pressure and it starts to phase separate and boils. You still have those fluids and they're still carrying that gold, but you might just end up with a different expression in it. And there's a whole continuum of deposits, very shallow level deposits that parts of the Selwyn Basin appear to be very prospective for. And we think that our package up in the eastern part of the Selwyn Basin is really prospective for a variety of these deposit types, including some sort of outside of the box thinking. This is a bit of a stretch, but so far the target kind of looks like it. We have a base metal project called Ursa, which was brought into our gold-focused company, our gold-focused portfolio because of some potential analogs to the Sukhoi Log deposit in Russia, which is one of the world's, if not the world's largest untapped gold reserve. So that's a resource there, 67 million ounces. Their reserve that they have published, I think, is about 42. So that's gearing up towards production. It would be lovely to find something like that. But at this point, that's pretty speculative. But again, that's sort of the name of the game as well. So this is just zoomed in on that corner of the Yukon. 4 of our 7 projects are tightly clustered here in this regional structure that has been referred to as the knot. It's sort of a big orocline that you can see in the Selwyn Basin sediments in the background there. And it's largely unexplored. We have over 100,000 hectares there that we've actually whittled down from a much, much larger land position that we held over the sort of 2010 to 2012 period. And so we have extensive baseline data, and we've really been able to efficiently hold on to what we see as the most promising areas and trends out there. And again, with that data, a lot of interesting targets have popped up. And I guess this is as good a time. If you haven't been following the Snowline story, I encourage you to. Our first season, we've tested 2 targets now of many that we've identified on the projects. Both have had gold discoveries in our drilling, significant gold discoveries, I would say. It's not my favorite metric, but the gram meter is often thrown around. And at Jupiter and Valley both, we found visible gold in drill core, and we have, as of this morning, with some results back from Rogue, from the Valley target, we've had 2 discoveries of over 100 gram meter holes on 2 different targets. So it's a pretty good first year, and it's a really good validation for our thesis that this area is an overlooked and basically unexplored gold district. Just a little bit of a background. It's not the most technical slide you'll ever see, but these background units are largely, they're, as I've mentioned, Selwyn Basin rocks, passive margin that stretch from basically the late Proterozoic to the Devonian. They were later deformed into this sort of regional orocline structure, almost like a taco shell or something to that effect, possibly a drag fold effect on the Hess-McMillan fault system, which is down in the southwest of the frame there. And areas, parts of this package have seen up to 80% shortening. So you just have these vertically stacked units, a lot of structural preparation, a lot of very interesting folding and faulting that makes for a very fertile environment. And of course, these rocks themselves hold large deposits. The Selwyn Basin rocks elsewhere hold deposits like Anvil Range, Howard's Pass, close to home, McMillan Pass. So big metal allocations, and of course, gold can be a component in that, and it is a potential source for these deposits. In the Cretaceous, as with a lot of the tombstone and male platonic suites, you have these felsic intrusions that are responsible for a lot of, and are really the type type intrusion for reduced intrusion related deposits. And right in the apex of this fold, you have several large plutons and several smaller stocks. And we've identified a few that actually are not on geological maps yet, and they seem to be quite prospective, as well as a few that don't appear to daylight, but we think that they're there based on the geochem, or the hornfelsen that you see on surface, the alteration from the heat of these intrusions, and as well as geophysical signatures. And then a last mineralizing event, you have emplacement of sediment hosted gold, more recently than 60 million years ago. And so any number of these, our valley mineralization is clearly associated to the intrusions, and it would be Cretaceous aged, but Jupiter is, it may be a distal expression of that, but it may be something coming from related to the Carlin style mineralization up to the northwest, or it may be even a result of the tectonic shortening itself and metamorphic fluids coming up from depth. So the jury is still out on Jupiter, but we're excited to keep looking and keep trying to figure it out. So zooming in on Einarson, you can see it's kind of a busy area. We've whittled the claim block down to really hold on to what we see as the best targets, and they're coming together very nicely and very quickly too. So we've shifted our focus from Carlin, although it's still very prospective for Carlin, to a series of orogenic looking, epizonal orogenic looking occurrences. And obviously this year we started drilling Jupiter. Prior to this season, it was a soil anomaly with some float train, basically, a few possible sources for it. But just these beautiful mineralized float boulders grading anywhere from 0.5 gram to up to 25 grams. Those were discovered by Wan Jin Yang, and as I mentioned, the Carlos brothers were out there very early, kind of shoring up that discovery as well, and did a lot of work out there. And we sort of had to we took it as far as we could, really, and had to take a leap of faith in terms of being confident that the outcrops we were seeing and the lineations we were seeing in the landscape made sense as far as potential sources for this float train, and it wasn't all just glacially transported. And so, we drilled a couple of holes, and sure enough, we got into the system very quickly, and from there, sort of refined how we targeted it. And by the 10th hole, we were into some pretty nice stuff. Well, even before that, we were into nice stuff, but we really kind of changed gears with hole 10 down at the south end there. I remember that coming out of the drill. I was just leaving that day, and some spectacular numbers, just zone after zone, and big zones of alteration around it with sort of pyritic clay altered halos around these mineralized veins. It's an exciting anomaly. So this year we did shore up the soil sampling with 1,300 more soils there, and on one other target on Einarson. And we drilled 4,300 meters in 21 holes. We did a lot of prospecting and mapping to kind of shore up our understanding of it, although we still haven't found any mineralized outcrops there, so it's all blind drilling. And then we did high resolution orthophotography and DEM generation with Vanessa Bennett, which has proven really useful here and on other targets. This is just an example. If people aren't using drones, I would definitely recommend it, just to get these really high resolution. I mean, LiDAR is similar as well, but to get these high resolution DEMs, it's very useful. You can see Vanessa picked out multiple generations, multiple lineations here that some of which appear to be controlling mineralization. And it's also very useful data for checking on geotechs to see if they're sleeping on drill pads. So multifaceted tool there. But actually the photographs are very useful as well when draped over the DEM. This is kind of a brushy area, but when you get up into higher country, you can basically just do a free helicopter trip to the property whenever you want and look at the prospects from all angles. So it is very useful data. This is sort of the meat of what we got into at Jupiter. Down in the south end again, just hole after hole with some very nice intersections, very nice grades, broad intersections, not just in the quartz zones, but also in the siltstones that this is hosted in. Just to look at the core quickly, you can see that it's a bit of a mess. There are breccias, there is a lot of arsenopyrite along these stylolites and intruding, or not intruding, but disseminated into the host rocks. As well as clasts, you have clasts that are almost completely replaced with arsenopyrite, and in places it can be difficult to determine whether you're looking at an accumulation on an open space of sulfides or a clast that's come from the wall rock. But it's really interesting mineralization. Very little metamorphism in the wall rocks. Clearly a shallow emplacement, brittle structural controls, and we've seen quartz kind of intruding into fold hinges, making little reefs. A lot of discordant breccias cutting across bedding, and veins and even sheeted veins, as you can sort of see here around this main breccia zone. A few more shots of drill core. This top hole is another zone from that cross section we saw. I should point out this hole 15 here was actually drilled about 150 meters north of that cross section, or at least north of the collars for the cross section. It's probably about 80 meters from the closest mineralization in that section. And so we were pretty excited to, again, step out blindly and keep hitting things like this. And then stepping out blindly even further with our last two holes, we went 1 kilometer to the north of hole 10 and drilled again just onto a geochemical anomaly and hit visible gold here and 4.7 meters of 8.3 grams. So some pretty nice numbers up there as well. And that's just a whole new part of the system that we've yet to dig into. And it really highlights the breadth of this anomaly. It's still open in all directions. And now we're finding, multiple hotspots along this larger trend. So it has us pretty excited to get back out there. Just a few shots of rock textures. Again, mineralization, gold mineralization seems to be tied closely to acicular, to sooty arsenopyrite. But there are fine-grained instances of visible gold as well, particularly, well, so far we've only seen it at the far northern end of the project in hole 20, but that was good to see. Some parallels in terms of what we're seeing in terms of styles of mineralization to a lot of the excitement coming out of epizonal orogenic systems in Newfoundland, and also, of course, in Australia with the Fosterville and Bendigo district. And then at the end of the season, we had a few weeks left, and we decided to jump down under a different target. We moved the drill down to the Rogue property, the Valley target, which is on that dense cluster of soil cells. Just for reference, that's about that claim block is about 10 kilometers across, and we've got 3 targets on it, unmapped intrusions, 2 of them, and then one of them is partially covered by another holding. But ultimately, we spent the season shoring up the Valley target and looking around a little bit more before drilling. And so our soil geochem from the Valley target really stood out. There are a couple of hot spots. This one is 900 meters long, and it corresponds with sheeted veining observations on surface and some high-grade rock samples that we'd found. We did a detailed aerial mag survey using drones or a drone, and that really outlined this anomaly, which again doesn't appear on any geological maps. It just goes to show the really greenfield nature of this area when you have a daylighting 1 kilometer intrusion that just it's not on the maps. And so, yeah, it's really unexplored country and proving to be very prospective. In all 4 holes, we hit instances of visible gold and sheeted veining. So this is a similar style of deposit. We hope to, what Tara was talking about and what you see at Eagle Gold Mine with Victoria Gold. And just this morning, we finally gotten some results back from not the first hole actually, but the second. And it was 1.1 or 1.01 grams over 136.8 meters. So again, another 100 gram meter plus hole. We were very happy to see that. And if you want more details, you can check out our news release from this morning. We do expect to have the results back from holes 1, 3, and 4 in the very near future. We have quite a few other targets. Those are just the 2 that we happen to drill. I wouldn't even say, well, they are among the best. That's why we decided to drill there, but we have some very good reasons to drill some other targets, and we're very excited about that. So this season, we'll see sort of a blend of drilling, doubling down on the discoveries we've made, fleshing them out, and trying to get them towards a point where we can start to see, start thinking about resources and that sort of a thing. But at the same time, we don't want to miss the forest for any individual tree, and we do want to continue looking at additional targets across the property package. We had a very successful year. We could not have done it without the Snowline Gold field team. The Snowline Board of Directors has been very active and very helpful throughout the whole process. And of course, one of the most rewarding parts about this whole journey so far has been supporting local businesses and working with a lot of very talented entrepreneurs and groups in making these things happen. It's a collective effort. And I'd also like to thank the Nacho Dun and the Nacho Dun Dev Corp for their participation through their economic incentives or economic efforts, I suppose, in starting companies like Big River, Yukon Seed and Restoration, and partnering with others to make this sort of work possible. So thank you very much for your time, and I look forward to questions.
Wow, another great talk, Scott. That looks like an awesome summer, man. Hopefully everyone is aware that if you have questions, you can throw them in the chat below, and we'll get to them at the end of all the talks. We're going to shift gears slightly, no less exciting, but probably, I don't know. I don't know if there's any numbers in this one, Diane, but we're going to have a YGS talk now by Diane Skipton, and she's going to give us an update on her mapping in the Nash Creek area, just northwest of the Keno.
All right, thanks for the introduction, Pat. I'll just share my screen here. All right, okay, so I'll be presenting the updated geology of the southern Nash Creek area. This is based on recent mapping. Great, all right, okay, so yeah, so my field area is located in central Yukon. So just on the terrain map there, it lies along the boundary of the Ogilvie Platform and the Selwyn Basin. And on the right-hand side there, that map shows the distribution of the sedimentary rocks in the Selwyn Basin and the Ogilvie Platform. So my field area is outlined in red again there, and it's mostly comprised of rocks of the Windermere supergroup, which are Proterozoic to Lower Cambrian. Okay, so looking a bit closer at the field area. So the map on the left, the area outlined in red is where I've been mapping the past couple of years. So prior to my project, this area was mapped at 1 to 250,000 scale by Green in 1972. So the area is mostly comprised of Neoproterozoic to Cambrian rocks of the Highland group, as well as younger rocks, including the Devonian to Mississippian Ern group. There's also some major faults that run through the area, including the Dawson Fault, the Tombstone Thrust, and the Robert Service Thrust. And one of the outcomes of my mapping is that the Dawson Fault, rather than kind of cutting across the field area like it does on the map on the left, it's actually a bit further to the northeast in the valley there. So looking at this geophysical map on the right, this is recent aeromagnetic data by the GSC. So I think the Dawson Fault is actually corresponding to this fairly strong linear feature, which I've outlined in yellow there. So in terms of the timing of deformation, the Dawson Fault is very protracted, has a protracted history from about the Neoproterozoic to, well, it's been reactivated at later times, so in the Mesozoic and probably the mid-Cretaceous. Whereas the Tombstone and Robert Service Thrust are older. So we have an argon-argon white mica date from the Tombstone Thrust Zone, for example, which is about 100 MA. All right, so this is a preliminary bedrock geology map of my field area. So this is at 1 to 50,000 scale, and it was conducted over 2 field seasons. And I have another field season planned for this summer in this area. So this area is really comprised of several different thrust panels that are between the Robert Service Thrust in the southwest and the Dawson Fault to the northeast. And I'll go through just to summarize what rocks are in each panel. So starting with the hanging wall of the Robert Service Thrust, we have the Neoproterozoic to Cambrian Highland group, which includes the Eusebio, Narchilla, and algae formations. And then moving to the northeast in the footwall of the Robert Service Thrust, there are younger rocks, the Mississippian tissue group and Devonian to Mississippian urn group. And the urn group unconformably overlies the Highland group. Moving further northeast, we have the Highland group again, also the Gull Lake Formation and younger Ordovician to Silurian Road River group. Further north in the next thrust panel, we also have the Road River group and some mafic volcaniclastic rocks. And then stepping across the Dawson Fault into the footwall, we have the Bouvet Formation, which is about Ordovician to Devonian. Okay, so the diagram on the top right kind of summarizes all those schematic stratigraphic sections, but really just shows how this area, the rocks of different ages are juxtaposed across different thrusts. The cross sections on the bottom run from southwest to northeast, and yeah, again, it just shows we have a number of thrust panels there. I'll talk about the structure in more detail later, but I just wanted to show the overall architecture before going through the different units. So starting with the oldest rocks in the area, the Highland group. This includes mostly the Eusebio Formation, which consists of sandstone, siltstone, and shale. So I've got some photos of the sandstones on the top, including quartz arenite and quartz grit sandstone. There's also the algae formation, which includes gray limestone, which overlies the Eusebio, and that's overlain by the Narchilla Formation, which consists mostly of fine-grained siliciclastic rocks, mostly shale, some siltstone, and minor sandstone. So I've done some detrital zircon work on the sandstone from the Eusebio, and it produced a maximum depositional age of 665 MA. So based on that age and also based on the broader stratigraphy, these rocks do correlate broadly with those elsewhere in the Sullivan Basin, such as in the eastern Rackla Belt east of the study area. So moving up section, the Highland group is overlain by the Gull Lake Formation. This consists of thinly interbedded siltstone and shale. And it forms tends to form scree slopes that have a really distinctive chocolate brown color, as shown in the photo on the bottom there. In this photo, the Gull Lake Formation is overlain by the Road River group. The Road River group is Ordovician to Silurian. It mostly consists of black mudstone and dark gray shale. There's also quite a bit of chert in the Road River, so sometimes it forms interbeds in the shales, and other times it forms fairly continuous sections of chert, which can be banded, as shown in the bottom right photo there. I also mapped some mafic volcaniclastic rocks in the northeastern part of the study area, so I've got that area outlined there in red. So these include mostly dark green to gray weathering mafic volcaniclastic rocks. So they have a mafic matrix and a class of mafic volcanic rocks. There's lesser amounts of basalt and mafic tuff, and also some interbeds of silver weathered dark gray to black shale. So the age of these rocks is unknown, but there is some evidence to suggest that they correlate with volcanic rocks at the McKay Hill deposit, which are estimated to be Ordovician in age. So the map I just brought up is by my colleague at YGS, Rosie Cobbett. She actually presented on this work earlier in the seminar series. So Rosie's mapping at McKay Hill has shown that there's a section or a sequence of volcanic and sedimentary rocks. And we believe that these are continuous to the southwest to the rocks that I've mapped. Okay, so moving further northeast, this is the Bouvet Formation, which is in the footwall of the Dawson Fault. So where I've mapped it, it's mostly gray limestone. It ranges from massive to medium bedded. It's often very strongly fractured and dolomitized, as shown by the photos on the top there. On the map, I've divided up the Bouvet into the lower, middle, and upper formations, and that's The exposure in my map area of the Bavette is not the best, but the stratigraphy is based on stratigraphic work that's been done in the surrounding areas to the east and west, the Tiger and Castle Mountain areas by other colleagues. But in this area, I've also found some volcanic rocks. These are pictured on the bottom there, so they're gray to beige weathering and fine-grained mafic volcanic rocks with some hornblende phenocrysts, and they're just shown on the map there in green. Okay, so moving to some younger rocks in the southwestern part of the study area. This is the Devonian to Mississippian Urn Group and the Mississippian Tissue Group. So the Urn Group in this area, which is shown in turquoise on the map there, it's mostly consists of fairly homogeneous dark gray shale. It also has a couple intervals of carbonate-rich unit, which is pictured on the top right there. It has orange weathering dolostone beds that are interbedded with white weathering fine-grained sandstone and chert. The tissue group consists of dark gray or gray weathering quartzite that forms very blocky outcrops. It has a medium grained crystalline texture, and based on its composition and stratigraphic level, I'm interpreting this as the Keno Hill quartzite. So both the quartzite and the Urn Group shale host numerous gabbro sills, which are part of the Triassic galena suite. So here's some photos of those sills. Previous mapping of this area had these sills as quite discontinuous bodies, but they're actually quite continuous and mappable from ridge to ridge, as shown in these photos. They're usually 10 to 15 meters thick, but they can be upwards of 50 or 60 meters thick. They're typically medium grained and equigranular, and in places they can be fine grained with plagioclase phenocrysts. The area also has some different gabbro intrusions that are hosted by the Highland Group. So I've cut out a detail of the map there to show those. There are these little green bodies there. I think the biggest that I've mapped, at least the surface exposure, is about 150 meters. They tend to be medium grained. They do have some primary minerals like CPX and hornblende, but they're usually quite strongly altered by carbonate and chloride and actinolite. So those gabbros that are hosted with the Highland Group or hosted in the Highland Group are actually geochemically similar to Cambrian and younger mafic sills and dikes in the surrounding area, including those in the eastern Ogilvie Mountains to the west, which I've circled in blue there, and the Dempster Volcanics. So looking at their geochemistry, the blue field is the compositional field of the Paleozoic and younger mafic rocks in the Ogilvies, and the gabbros hosted by the Highland Group at Nash Creek are shown by the yellow dots. So they do have a similar geochemistry, whereas the Triassic gabbro sills of the Galena suite, they define this green compositional field and they're geochemically distinct. I also found some a felsic intrusion, a quartz monzonite. This is shown by the pink star on the map there, so just on the southern edge of the area that I covered. It's hosted by the Eusebio Formation siltstone. It's medium to coarse grained and very strongly foliated, very pervasively altered by carbonate and quartz. However, its age and geochemistry are yet to be determined. And also its extent, I'm not sure really how big it is. It's in a very heavily vegetated area with very little exposure. But the surrounding area does contain several felsic intrusions that this quartz monzonite may or may not share affinity with. So for example, there's the Rackla granite to the east, which is about 60 MA. There's also the Dublin Gulch and Mayo Sweet plutons, which are to the southwest, and they're about 93 to 94 MA. But the quartz monzonite is very strongly foliated, and based on what we know so far about the age of deformation, it could be quite a bit older than those plutons. So it may instead share affinity with the felsic volcanics in the Urn Group, which are shown on the map in bright green there, which are about 378 to 380 MA and sort of south of the study area, they host the Marg VMS deposit. Okay, so I'll talk a little bit about the deformation here. I've shown these cross sections earlier in the talk, but I'll talk about them a bit more now. So they go from southwest to northeast, and looking at the long cross section on the top, the southwest portion, which goes through the Robert Service Thrust, has fairly shallow to moderately south dipping bedding, whereas as you move further to the northeast, closer to the Dawson Thrust, the bedding, everything steepens up. So bedding is almost subvertical in some places, and you get quite tight isoclinal folds. Whereas looking at the shorter cross section, B to B prime, in that area, the style of folding is a bit different. Even within the same thrust panels, the folding is a bit more open in general. So there are some different structural domains that we can break out there. The bottom left photo shows an example of that open style of folding. So this is a complexly folded interval of the limestone in the algae formation in light gray. And it's in a broadly synclinal geometry with the Narchilla formation preserved in the synclinal keel. There are numerous other folds throughout the map area. The folding is very common at outcrop scale. I've just shown a couple examples here. These examples are a bit asymmetric. They have a short, steeply dipping northeast limb, which suggests northeast vergence in these cases. The Robert Service Thrust is actually very well exposed in the field area. So looking at the bottom left photo here, this is the couple clip-in that I've mapped. So I've been able to map the main thrust surface, but also two clip-in, which are quite well defined. You can see the sort of lighter weathering highland group has been thrust over top of the gray weathering Keno Hill quartzite. The intensity of deformation is actually quite a bit stronger in the Robert Service Thrust than elsewhere in the field area. So in these photos, there's quite tight to isoclinal folding, both in the hanging wall and the footwall. And some of the folds do have an asymmetry that suggests northward vergence. So overall, the bedding and foliation in these rocks throughout the study area has a moderate to steep dip towards the southwest or northeast. Foliation is commonly oblique to bedding up to 90 degrees, as shown in the photo on the bottom there. There are also northwest to southeast plunging fold axes and crenulation lineations, and all of these fabrics are consistent with synclines and anticlines that have northwest to southeast striking axial planes. The area has been regionally metamorphosed at lower greenschist facies, so in the chlorite zone. So estimated temperatures are between 300 to 400 degrees. The clastic rocks contain metamorphic white mica and chlorite, plus or minus epidote. And in some cases, there's chloritoid porphyroblasts as well, which I've shown on the bottom left there in the photomicrograph. There's evidence of, broadly speaking, two main foliations. So there's one early bedding parallel fabric, and there's a second later fabric that dips towards the southwest or northeast. This is shown in the photomicrograph at the bottom right, where you have that the S2 fabric is cutting diagonally across the photo. And both of those fabrics are defined by the greenschist species minerals, mainly chlorite and white mica. So there are quite a few quartz veins throughout the study area. They're mostly hosted by the Ussezi Formation and the Narchilla, and less commonly by gabbro that intrudes those units. I've also found quartz veins hosted in the Rogue River Group Chert and Keno Hill quartzite. The veins contain chlorite and white mica, carbonate. Occasionally they'll contain sulfides, mainly pyrite. And sometimes they have an associated alteration zone, like a gossinous weathering around them. The veins are mostly parallel to the regional fabric, so they strike northwest, southeast, but they do have various orientations and can sometimes form networks. They sometimes have associated silica alteration zones, so the rocks can be have a white bleached appearance, which is shown by the sample in the middle on the right there. And I have collected a number of assay samples from veins across the study area. But one of these veins actually did return some interesting assay results from the grab sample. So it contained 5.58 grams per ton of gold and also 2.2% copper, over 1% zinc. So the location of this vein is shown in the yellow star there. So it's roughly in the middle of the area, and it's hosted by sandstone in the Narchilla Formation. I've got a photo of the vein here. So it has quite a bit of this brown, rusty colored material, which may be altered or weathered sulfides. There's also some blue and green mineralization, which I've circled in red there. And on the bottom, that's a photo of the outcrop where I sampled. So the vein itself is in the foreground there. I've kind of circled the area where I sampled. The vein is discordant with the foliation and bedding in this area. It dips towards the southeast, and the vein is about 1 meter wide. Yeah, so that's my talk, and thank you very much for listening. Yeah, if you need any more information, all of this will be written up in a YAG article, which will come out in the next few days. I'm also putting out an open file of the geology map, and you can always email me or call me if you have any other questions. Yeah, thank you very much.
Man, even a survey geologist can come up with a massive number in this area. Hey, it's got to be good. Well done, Diane. That was great. It's really great to see some structural and metamorphic work happening in those in that area, and I think that's going to be super helpful for exploration. So thanks for that. We're moving down now to Kim Tyler with Stratabound down to southeast Yukon. Kim, I'll let you tell us what it's all about.
Thank you once again for the invitation to participate in the Yukon Geoscience Forum. I missed last year, we weren't in it, but we were in it 2 years ago, and there's been a lot that's happened in that time. So we'll go to that and discuss it. Forward-looking statement. I tell everybody it's certainly the junior exploration world is very, very risky enterprise for people to get into, but lots of fun. So overview here, what's going on? We're in the eastern Yukon. Great talk just earlier on by Diane, leading up to the northern part of where we are. I like to say that this whole eastern part of the Yukon is the little that has been explored, the little property available to explore on. There seems to be a lot of gold on it. A number of properties up and down from south to north. You can see the projects in there. It's underexplored in my opinion. I just said there's wherever you look, you're going to find something. You got Stratabound now controls about 99 square kilometers of property, about 28 kilometers of mineralized trend, of which only 20% of it really explored very seriously. We're 25 kilometers north of Seabridge Gold's Three Aces project, and that was what brought me into the Yukon back in 2016 to look around. Was that 5,401 gram per ton discovery on a trend parallel to we believe we're on at Golden Culvert. But pretty exciting discovery, and now Seabridge Gold has picked that property up about a year ago, and I understand they'll be working on there this season coming up. The 10-year Class 3 permit we have on the main Golden Culvert. We're Class 1 on the Little Highland portion of it. All season road to the property. We can get there year round. So to date, we have drilled 25 drill holes. When we first picked up the property in 2017, Stratabound Gold, it had a soil anomaly on it and some hammer and boot stuff. The prospectors picking up samples, about a couple of dozen samples that assayed between 7 grams and 22 grams. A little else had been done. Since we picked it up, we put a road into the drill site, to the main zone. Our work is focused mainly on a little box, kilometer long, sitting right down here. Yet we control this property package from north to south. The drill results that we've gotten, first drilling we did in 2018, and then again in 2020, totaling 24 drill holes and 25 drills, 24 trenches over that kilometer strike. Values up to 60 grams over 9 meters. We have a high grade core, usually within the quartz veins, vertically dipping, and a lower grade halo around it, typically around up to 7 meters on average width, and either to collect to get over across the full width. In this case, one hole, 2.5 grams per ton over 33 meters down the hole. Best trench result we've had is 24 grams over 6 meters, includes 95 grams per ton over 1.5 meters. And one thing I'll talk to in a bit, we get further, something that we noticed and didn't pay a lot of attention till about 2020, that season, was boulder trains lining up between the outcrops. When looking at the property in 2016, looking at the main outcrop, I say it looks the size of a school bus, a meter wide, meter and a half wide, quartz vein running through it, running up to 22 grams. Scree and Talus Slope, I walked up about 800 meters up the hill and sampled another vein lining up the first one, and it ran 8 grams, and it was, again, 800 meters away. So pretty interesting project. But the point was, in between was a boulder field that lined up numerous parallel quartz veins, and we sampled those, and more talk about it later, how these the results of that were pretty extraordinary. So since all that work's been done, what do we think we've got? We've got a multiple zone corridor, multiple gold bearing veins with low grade either side of it, halos around it, about 130 meter wide corridor along 970 meters of strike, open in both directions. We've drilled it to 225 meters and still gold below. And in 2019, we came to the new discovery 7 kilometers along strike. We really only focused on this little bit. This is the main Golden Culvert claim group. Little Highland is north and south. We control all that package. And we really only, the soil sampling that had been done was really focused around the Golden Culvert. And this is the work that we did, most of it in 2021. And we'll talk about the results of that, about the new soil anomaly that we came across. So background, we're in the Highland group of sediments within the Selwyn Basin. It's a host of several significant evolving new gold projects. You see them listed here. We got Gold Strike, Golden Culvert here, 3 Aces, Frog, Seabridge, Dronzak, Justin has Avon Resources, and Highland down here to the south, all in the same belt. More detail modified from Dave Moynihan in 2018, a little more detail. I think the key here is that you see 3 Aces, Sprague and Justin, sitting in the Cesu formation. Ours is in the Vampire formation. It's a younger age rock, equivalent to the Narchilla. Fassie's equivalent, I understand, of the Narchilla, which overlies the Cesu, but all the excitement has been in the Cesu. And as I said, I think back in 2018, are there any other gold showings of any kind in the Narchilla or Vampire out there? If there are, I'd like to know, but in our area, we're the only one. What does that mean? That means there's quite a distance between vertical extent to where we would be up high to get down to where it might be a 3 Aces below us, is the point. This is simplified. This figure 3 comes from roots from 1998, 2003. But here's where Justin Plateau, 3 Aces and Plateau located in the mid Cesu. Justin up in the higher part of it. We're up in the Narchilla or Vampire equivalent. What is that vertical depth? I don't know, but it's certainly some significant depth. It's an orogenic type deposit. These deposits are known to be deep. They can go quite a ways. So we know we're at the top of something. What's down below us is yet to be found. This is something else I lifted and cartooned over the top of Hart and Lewis's work from 2005. Golden Culvert's discovered 3 years later in 2008. So their work, the purple and the yellow lines are what I put in, and the red dashed line is I cartooned over top to try and give you an idea of what we think. 3 Aces sits about here from the work. This work plugged in from the work that Golden Predator had published in their 4310 and shows them that at an anticline. The gold mineralization, as far as we see, is structurally controlled, usually along the axis of an anticline of some sort, fold axis. That's what is interpreted here. If we follow that unit back through where it should be below where we are, we sit up top here in the Vampire formation. Potentially there's a 3 Aces down below, but I guess the point is that there might be a semi-continuity of gold mineralization that's as an exploration target that we could be looking for. Considerable, I'm not sure this scale, I doubt it's that long, but that would indicate 10 or 20 kilometers. I don't know if that's true. But in any case, there's certainly an opportunity here if you're looking deep. If we've got gold in our surface here, there's potentially a 3 Aces down below us. This slide is what I showed at the presentation in 2018. This is the work we had done to that point. We had about 6 or 7 drill holes done at that time, the very first drilling done on the property. This soil anomaly had been done prior to us acquiring it. It highlighted the original showing, I guess, is right through here that ran up to The main showing sits right in about here, the discovery vein up to 6.67 grams per ton. But the anomaly was for about a kilometer, 3 kilometers long. You can see in the green, plus 30 parts per billion anomaly. And the work that was done then. At that time, we thought we had 2 structures. We weren't too sure what. Next slide is the work that's been done since. Very busy slide, lots of information on it. But we're seeing all the trenches and drilling that have been done since. The 25 drill holes and 24 trenches are lined up in here. Same soil anomaly, but what is the meat behind the skin underneath it? All these dots line up, which indicate the parallel zones. We figure there's about 5 or 6, maybe a splay. We're still to be interpreted. 130 meters wide again, and about a kilometer long. And all these results, the purple are bonanza grades, and the 118 grams per ton, the 320 grams per ton, and so on. The red would indicate more underground type of grades, and the green would be the lower grade that would be amenable to perhaps open pit. So a lot of work focused around just 1 kilometer. This little box here, we'll talk about it again in a minute, but a cross section showing the same sort of thing. This is what we think we have now. Vertical structures that they may be either they're semi-continuous, boudinage, we believe, where their boudins come in. You're going to see microfracturing, crackle breccia, and arsenopyrite. The mineralization continues even though a consistent vein may not occur. Plus penetrative sulfides into the wall rocks on the side of the veins. And a long section here as well. We're looking at about 2 kilometers. The main zone of focus has been down in here, but even so on the flanks, historically prospectors have found float samples sitting up here earning 4 grams, 3.5 grams. And this is again, is just that this is probably the golden culvert claim group. We're still not looking at the full 28 kilometers of strike out control. This is an extraordinary thing we did in 2020. This is where I said we went back and sampled the float trains that existed between the outcrops. The main outcrop sits down here, down below here. The road was put in by us, drill road we ran through, and finally went through and said, let's sample these float samples. And they were selected because you couldn't see gold in them. One of them had visible gold, but otherwise you're just looking at scorodite, arsenopyrite altered quartz, and they line up, take you back to an outcrop or a trench. And here's some of the values. So it's extraordinary that 92 of those samples were collected and an averaged 8.85 grams per ton. And I said, it sounds promotional, but it feels like I was walking across a naturally occurring ore pile sitting up there. So it's quite extraordinary to see all these. And I guess that's the exploration tool for us to find, is just follow the float. And if hopefully it tracks you back to a vein and keep on going and pursue the rest of the exploration on the rest of the property. The other thing we came across in our work in 2020 was it had been pointed out to us that on the Nahanni Range Road to the north, where it curves back to the Cantong mine, is an outcrop of quartz pebble conglomerate, and that's a significant unit, we believe. Otherwise, the geology is very dull and boring. There's a lot of phyllite material. It's hard to distinguish it, where sometimes it alters and becomes more of a shale or slate, but it's really nothing much to be seen. We're really looking hard for a marker unit, and this would be an excellent one. We know that the quartz pebble conglomerate, if not this one, another one similar perhaps, is a structural control for 3 aces. So this is very important to us to do. This season we hiked up and mapped it, and you're seeing where it occurs, and it disappears about this point. This is looking to the south from that high point of the Nahanni Range Road. Beyond here, you don't see too much of it. Here's of course what it looks like, a sawn section here, and the way it looks like on the outcrop. See a close-up of this inset right here. When we need to do more work to follow that. Here's where it would occur, the Nahanni Range Road here. Here's where that outcrop occurs. We're just looking back this way, and here's where it's mapped. And at this point, it vanished under cover, and we could never pick it up again. And I'd have to admit, not a lot of work was spent mapping and looking for it since. But where does it go? And are we at a fold axis through here? Not sure. This is the north end of the property. This would be a soil anomaly called the Camp Zone that was known about in 2013. We've subsequently soil sampled all through here, but in 2019 we tracked this down and looking at this 530 ppb soil anomaly up in this area in the Camp Zone, tracked along and discovered a vein and sampled it. And there's Gary Lee standing on it right here. It's striking off in this direction, sampling it, getting 1.6 grams per ton and 1 gram per ton. Not extraordinarily high grade, but 7 kilometers away from the main zone, and we really don't know a lot in between. We had really not done any exploration, had never been soil sampled up until last year. So this, the main work of the main zone, here's the Nahanni Range drone running through here. Here's the, right through here is where that quartz pebble conglomerate disappears about the tip of that arrow. We don't know where it goes beyond here. A lot of really boring phyllites to work through here. Fold axis appears to be running through the center where the mineralization is. And all we knew when we walked into the property with this green plus 20 parts per billion soil anomaly. And the focus of work you looked at is all that drilling and trenching focused right here to understand as much as we can have. We didn't know anything about the rest of the property, very little. Hadn't been walked on very much, a little bit of soil sampling. All the soil sampling here, see here, was done in 2021. And we got an anomaly. We got a couple of anomalies, about 7 kilometers long of anomaly, very similar to the main zone. Tried to get out there in September, couldn't get onto the property. Got weathered out, the weather sank in, and then that was it. And we got, of course, we know it probably got 20 or 30 feet of snow out there now. First thing we're going to do next spring when its soil's gone, when the snow is gone, is get in there and land in and boots and hammers and see if we can find, we have a vein map here. It looks like the vein may be coming through here, but we'll get on there and check that out, see if it looks like the main zone. Maybe an offset, not sure. Very exciting to be looking on that next spring. Plus, up to the north in the Rubus zone, we've got another soil anomaly up in here to follow up in next season as well. And we really don't know what's happening down to the bottom part. Some ridge and spur sampling didn't show a lot, but it's a lot of this soil anomaly projects right on top of that for exploration following up. This slide you might have seen before. It's that one hole just to show the type of rocks we're looking at. And this would have been our best intersection, 2.5 grams over 33 meters. Seeing some of the grades through here. 1460 grams ran through here, a big high grade section. This stuff is interesting. When you see this, it's very distinctive. It's got that apple green looking crackle breccia. You're seeing vein here, obviously, but the grades continue on into the wall rock, and sometimes it's not all that, doesn't stand out all that well. But this crackle breccia is quite interesting with the arsenopyrite as well. I am through my slide presentation. If there's any questions, whatever time we've got left, happy to talk to it.
Okay, thanks for that. Great presentation, Kim. Hopefully there'll be some questions. I would assume there's some questions for you just shortly here after we do one more talk. So the last talk of the morning is a little different in a few ways. Geologically, we're going to go down to the Bennett Lake area. So we're leaving the Selwyn Basin. And technologically, we're going to go from a live presentation to a pre-recorded presentation. Ryan Berkey has pre-recorded a presentation on his Warden Pike project, new discoveries and new potential in the Bennett Lake Caldera Complex, Southern Yukon. And Anne, you're making it all happen right now, so I'll get out of the way.
All right, hello everyone. My name's Ryan Berkey. Today, I'm going to be talking to you about a project I've been developing over the past 3 years called the Pike Warden project. Now, this project would not have been at all possible without the support of the Yukon Mineral Exploration Program. So a very big thank you to everyone at the Yukon Geological Survey for seeing the potential in this area that I did initially. So, and obviously thank you for the continued support. It really, this project and the amount of data on it would be a fraction of what it is today without that program. So again, thank you. Also, thank you to everyone who's helped me develop it. It's just been a fantastic run. The last 3 years have been a lot of fun, and there's lots of more work to do. So I've got a lot of stuff to go through today. Hopefully I'm going to get it all done in 20 minutes. So I'm going to talk really fast, and I hope you're on the edge of your seat and you got a fresh cup of coffee in your hand, because I'm going to try and run through this stuff very quickly. So the title of this talk is New Discoveries and New Potential in the Bennett Lake Caldera Complex, Yukon. And first, I'm going to be talking about the project location, brief history and background, simplified regional geology, the property geology and the showings, and then finish with a working geological model. Try and tie all of what I've been finding together. So the project is located 70 kilometers south of Whitehorse, 30 kilometers west of Carcross, within the traditional territories of the Carcross-Tagish First Nation. And this picture on the right here, you can see the access to the property via the Annie Lake Road takes you to within 15 kilometers of the property boundary. The property itself consists of 185 claims covering 37 square kilometers, and it lies just south of Whitehorse Gold Corp's Skookum Gold Project, which contains the past producing Mount Skookum mine, as well as the advanced stage projects Goodell Gully and Skookum Creek. Now, zooming in on this area, why did I even start looking in here in the first place? Well, I'm sure all of you know who are listening, Mount Skookum was a producing mine from 1986 to 1988, produced roughly 80,000 ounces of gold over the 3 years that it was producing. And it currently contains a resource of around 27,000 ounces of gold at 9.5 grams per ton. And there's 2 other significant advanced stage projects within the in and around the Mount Skookum Volcanic Complex. So you've got Goodell, around 200,000 ounces gold equivalent at 7.5 grams. And then Skookum Creek, the largest of the 3, 350,000 ounces gold equivalent at around 7 grams per ton. So this is great mineralization, good high-grade gold, silver mineralization, and all focused around the Mount Skookum Volcanic Complex. So these Eocene age volcanic complexes are very important for mineralization within the region. Look to the south, here's the Bennett Lake Volcanic Complex. There it is. It's Eocene aged, it's underexplored. I mean, the Mount Skookum Volcanic Complex is even underexplored. So move further south and it's even less so. And the Warden and Pike stars that you see on the screen here, those were 2 discoveries that were made in 1988 when Mount Skookum was producing. However, unfortunately, it was the final year of their production. So after that mine closed, these 2 great discoveries of 1988 received very limited follow-up work. So what were those discoveries? In the cirque of Mount Ward, we've got 3 different vein systems that were identified that returned peak values of almost 20 grams per ton gold and almost 400 grams per ton silver. 6 kilometers to the south, you have the discovery of the ERT zone, which returned phenomenal values of 5.3 grams per ton gold and almost 9,000 grams per ton silver. So unfortunately, never received the follow-up that they deserved. Now, just to highlight how underexplored the Bennett Lake volcanics are compared to the Mount Skookum Volcanic Complex, I drew this line and summed the claimed expenditures and that assessment report's footprints layer, and these are the results. So north of this line, you've got $13 million claimed expenditures around the Mount Skookum Volcanic Complex, and south of this line, you only have $1 million, so exponentially less explored. Similar age volcanic complex, in my opinion, fantastic geological potential, especially given those 2 discoveries in 1988 that received limited to no follow-up work. So does that lack of expenditures mean lack of geological potential? No, this is opportunity. Nobody's found it yet. So we've got to go in here and we've got to take a look and see if there's anything that was missed 30 years ago. I mean, the geology back then was fantastic. The assessment reports are of very high caliber, but still, there's a lot less work that's been done. So somebody's got to go take a closer look and follow up on that good work of the 1980s. So zooming in, take a step back here. Why is the Bennett Lake Volcanic Complex important? And why do I think it has potential? Well, I've already alluded to it, but more specifically, there's 10 volcanic centers within the Bennett Lake Volcanic Complex that you can see here. And then there's also this northeast trending hinge zone. Now, that's a very important structural zone. You need to understand the evolution of the Bennett Lake Volcanic Complex, and then it starts to make sense. So this complex, it started to grow and grow and grow, and then it had a collapse. And when it collapsed under its own weight, there was differential subsidence. So there was lots and lots of subsidence along the northern edge, and there was very little along its southern edge. So it needed to kind of flap, like it needed to hinge. So this hinge zone is the area, it's like an inflection point where that subsidence occurred. So it's like a hinge zone. Yeah, it's a flap where this differential displacement is being focused along the hinge zone. And the Bennett Lake Volcanic Complex not only collapsed once, it actually collapsed twice. So after its first collapse, there was the injection of the quartz feldspar porphyry ring dike along its northern edge. And then it grew again, had a resurgent phase of doming, and then it collapsed a second time. And these 2 volcanic centers were actually inferred to be active during during caldera evolution and also after collapse. So you've got two hydrothermal fluid sources, and you've got this great structural zone here. So this is going to channel hydrothermal fluids along these large scale structures that develop during caldera collapse. And that's why this area is important. So looking at a section of that, you've got this A to A prime pre-collapse diagram of what that would look like. You've got your magma source, brecciation in the overlying granitic rocks in your volcanic complex, which then collapses, differential displacement, and this northern edge has greater displacement than the southern edge, which has little to none. So that is sort of the kind of system that we're in here. So zooming in on the area, property geology, this is what it looked like in 2019, the 3 historical vein showings within that cirque and the ERT zone to the south here that was discovered in 1988. And in the previous 3 years, this is what the project looks like now. So you've got mineralization all channeled along this hinge zone. You've got anomalous soil and till geochemistry, as well as lots of separate showings in and around the property. And so what have we done out here to generate this, this development over the past 3 years? In 2019, there was 2 of us, myself and Charlie Pike, a university colleague, for 9 days, till samples, rock samples, claim staking, geological mapping, which led to 3 people for 10 days, 250 till samples, additional rock samples, additional claim staking, detailed drone surveying in the cirque here, as well as right here, and then ground magnetics as well, which led to 2021 work consisting of a 395 line kilometer airborne survey. There's magnetic, VLFEM, and radiometric data, 299 rock samples, and 4 hand trenches at the historical ERT zone here. So quite a bit has been done in the previous 3 years, and there's lots of new discoveries. So I'm going to go through those with you today. And these are kind of the most important 5. This is the distilled kind of mini version of the highlights of mineralization. So first, the ERT zone, second, the silver train, third, the bonanza zone, 4, lead gold saddle, 5, the upper saddle. These 5 showings have a strike length of 5 kilometers, and I think that they're all related, and I'm going to try and tie those together in the working geological model at the end. So there's a really, having that hinge zone being on the edge of the volcanics, you've got a good geology story here, and I think all these showings are related to the same mineralizing system. Not necessarily the same event, but at least the same system. So looking first at the ERT zone, this is the 2021 prospecting team. You've got Luke Carlos in the back here digging a hand trench, Shane as well, Shane Carlos, and then Charlie Pike, the human helicopter flag. This is one of the best prospecting teams that I've ever had the pleasure to work with. So fantastic, and thank you guys very much for your hard work on the project this year, or the previous year. So what is the ERT zone? It's a tabular, moderately dipping zone of mineralization exposed over 30 meters with anomalous silver arsenic geochemistry extending 250 meters east and west of the main zone. I think it's a drill-ready target with bonanza silver grades. One of the highlights of sampling from this year, a grab sample, quartz sulfide breccia, fine grain, 11,270 grams silver, 1.26 grams gold. So what did we do here? 4 trenches. There's 3 historical ones, east-west trending, and then we put in 4 north-south trending trenches where we believe to be across the zone rather than along it. But highlight results here. We've got 90 grams silver over 3.6 meters, 160 grams silver over 3 meters, 307 grams silver, 1.46 grams gold over 6.6 meters, as well as 346 grams silver and half a gram gold over 4.7 meters. And then the real highlight here, that trench from the previous slide that you saw the picture of, was mineralized across its entire length, 486 grams silver and 0.3 grams gold over 8 meters, including a higher grade interval of 761 grams silver and 0.4 grams gold over 5 meters, and open to the north here. So phenomenal, great trench result overall. Really consistent mineralization across the zone so far. Highlight grab samples, only 17 samples have been collected outside the zone of trenching. So this really is underexplored and needs more work. 1,300 grams silver, half a gram gold, 0.73% lead, 600 grams silver, 5.5 grams gold, 0.2% lead, Down here, 480 grams silver, half a gram gold. And then a real kicker here, 5,000 grams silver, 2.14 grams gold, 0.18% lead, and 0.5% zinc. And then, like I mentioned in the previous slide, you've got your highlight sample here, 11,270 grams silver. So just phenomenal. Open for more trenching, open for more soil sampling, as well as anomalous geochemistry to the east and the west as well. So very interesting zone here. Moving on to the silver train. This is a very interesting 500-meter square area consisting of quite a bit of very oxidized quartz vein float, typically along these interpreted structures, which are east-west trending as well as northeast trending. Peak values of 7.5% copper, 643 grams silver, 1.6 molybdenum, and 0.7 grams gold. There's quite a bit of propylitic alteration within this area. The granitic rock is this biotite hornblende granodiorite. There's also rare hematitic and potassic alteration mixed in. And this is an example of kind of these oxidized veins that we've been finding. So 493 grams silver, yeah, good result here. And you can see that it's just extremely kind of like a glassy, oxidized hematite, limonite-rich quartz vein. So a plan view map of this zone here shows that of the 141 samples collected in the area, 15% of them are returning values greater than 100 grams silver. And I'm just going to show you some highlight results here. So you've got 470 grams silver, 643 grams silver with 1.4 grams gold, as well as elevated lead, 5.35% copper, 493 grams silver. This is a chip sample from 2021, 32 grams silver, 0.64% copper, and 0.1% moly over 2 meters. The very nice copper number from a vein discovered in 2019, east-west trending and dipping towards the south, 7.5% copper. And then looking now at the molybdenum values, which I find quite interesting, 25% of the samples collected to date are returning greater than 0.1% molybdenum, especially centered over this 500 by 300 meter area. So that is really interesting, these elevated molybdenum values, as well as you got this nice base metal signature with copper and silver as well. Some elevated tungsten values in there as well. So are we close to a buried mineralizing pluton? Could there be porphyry potential beneath this zone? Someone needs to go in and do a little bit more work to figure that question out. Thirdly, the Bonanza zone, 800 meters to the north. This is the zone I'm most excited about personally. First discovered in 2020 with this quartz sulfide vein here that returned 48 grams gold that I found within this talus slope here. And follow-up work in 2021 discovered 4 flow-banded rhyolite dikes. The bottom north-south trending exposed over 300 meters strike. The other 3 unknown strike length. However, they are northeast trending flow-banded rhyolite dikes. And additional prospecting in this area returned 3 more high-grade gold samples right from this star here, which is a recessive kind of linear bench northeast feature, which is obscured by talus. So there's kind of sporadic float in the area, but it's a great trenching target. And I really do think that there could be a mineralized vein adjacent to this flow-banded rhyolite dike. Why this is exciting is because this is exactly like the mineralization observed at Skookum Creek, Whitehorse Gold's largest of their 3 deposits they're currently advancing. So at Skookum Creek, you've got veins that are developed along the margins of these northeast trending dikes, particularly the flow-banded rhyolite dikes. So the fact that there's 4 flow-banded rhyolite dikes here that are very underexplored, and one of them is returning high-grade gold values closely associated to it along a northeast trending structure is very, very encouraging. So I cannot wait to get back here. The 3 samples of this year, 8.6 grams gold, 16.8 and 30.2. So looking at these closer, you've got that 30.2. This granitic rock looks kind of sheared and it has lots of quartz veining through it. So potential for mineralized wall rock here adjacent to the veins. The original sample, 48 grams gold, very sulfide rich, quartz sulfide breccia. And then as well, you've got this 8.6 grammer. That's kind of these 2 tabular oxidized quartz veins with very altered ground diorite or something in between there. And then this 16.8 gram sample, similar to the 48 grammer, this very sulfide rich quartz sulfide breccia. So moving 2 kilometers north to the lead gold saddle, this is a discovery by Luke and Shane Carlos made in 2021, where you've got these beautiful coarse grained quartz veins with nice euhedral quartz and this very, very, very distinctive semi-massive galena infill. So when I first saw these samples, my jaw dropped and I thought, wow, these are going to be really good lead values and really good silver values. But when the assay sheet comes back, they're enriched in precious metals as well. So really nice surprise there, I'd say. This sample here returned 44.5 grams gold. This sample over here, 60% lead, 490 grams silver, and 4.3 grams gold. And this sample over here, 11.3 grams gold, 31 grams silver, and 7.3% lead. So you've got this base metal rich vein that visually looks like it's going to be only base metals. And then when you get the assay sheet back, it's enriched in gold. So is this a base metal event that's overprinted by a late precious metals event? I don't know. But these 3 samples were taken across 140 meters. And this area has seen just 1 day of prospecting, so it needs follow-up work. We got to find the source of this vein. So again, lead gold saddle looks great. Can't wait for more work on there. Fantastic results, very interesting. And lastly, 5, the upper saddle. This is a 130 meter long, recessively weathered, east-west trending oxidized saddle that contains high-grade gold, silver, quartz limonite veins near the top of it. So it's a great follow-up trenching target. And there's some great numbers here too. You got 1.8 grams gold, 820 grams silver, 0.22% lead, and 0.14% copper, as well as another sample, 2.4 grams gold and 443 grams silver. So, I mean, this is great. You've got 5 fantastic high-grade showings, varied geochemistry, very interesting. And how does this all tie together? Well, this is my working geological model. So this is a long section, sort of along the trace of that hinge zone that I mentioned earlier. And then you've got your ERT zone, the silver train, the bonanza showing, as well as this lead gold saddle. So how are these all related? Well, obviously you need a buried magma source. This is the parent magma to the Bennett Lake volcanic complex. And then as that complex is growing and growing and growing, it collapses, which creates these large scale caldera bounding structures, which the majority of those structures are focused along that hinge zone. And then you've got that injection of the quartz feldspar porphyry ring dike along its northern edge, which might cause some mineralization at the ERT zone, as well as silver train. But then you've got this resurgent, you've got continued volcanic activity further to the north along those structures. And then you've got resurgent volcanic activity and magmatic activity, which is that main mineralizing event of all the base metal rich kind of signature that we see across a lot of these showings. So that is maybe when you have your porphyry potential occurring at the silver train, as well as this quartz galena rich mineralization you're seeing at the lead gold saddle, as well as some of these kind of silver rich endowment over at the ERT zone with lead and zinc and copper as well. And as that system wanes and things start to cool down, then you've got your precious metals overprint along those reactivated structures. You've got your formation of the bonanza showing. Could that be an analog to Skookum Creek? The flow-banded rhyolite dikes are there, so that's a really encouraging thing to see. And then also the precious metals overprint you're seeing at that lead gold saddle. So all this stuff is really related to that continued magmatic activity and pre-existing large-scale structures that are all related to that Bennett Lake volcanic complex. So heavily underexplored and very much mineralized, so neglected in comparison to the Mount Skookum volcanic complex. And if you're not excited about that, I hope at the very least you're excited about the showings on the property, because I think they're phenomenal and they all deserve follow-up work, every single one of them. So thanks again for listening. Again, my name's Ryan Berkey. This is the crew in 2020, myself, Charlie Pike, Michael Hunter, and Mike Berkey. Now it's the 3 human helicopter flags. All I've got is this little piece of pink flagging, so I don't think that's going to cut it for me, but we've never had any safety incidents out there. It's been a good program every single year. So thanks again for all the support, and my contact information is listed below. Sorry I couldn't be here live. I'm traveling out of the field today. So yeah, I'm still working in the dead of winter running a drilling program. So it's lots of fun, but I definitely like hiking in the mountains in the summertime as well. So thanks again. If you have any questions, don't hesitate to get in touch. And yeah, I hope you enjoy the rest of your day. So.
Not that you can hear it, Ryan, but great job. Maybe Mike, you can pass along the great job on the presentation to Ryan. If I couldn't get all the speakers to turn their mics and cameras back on, we will now do the live Q&A. Again, just to reiterate, even though Ryan was a taped presentation, Mike Berkey is here to answer any questions you might have on the Pike Warden projects. Okay, I see Diane's not on, but maybe I'll start with some industry questions. Scott, I'm just gonna go, I don't know if you looked in the Q&A session. Did you see that question? It's anonymous, I don't know where it's from, but did you see that one?
No, sorry.
So if you look along the bottom, there's a Q&A. I can read the question out. It's for Snowline.
Okay,
I'll just read it out and then maybe you could respond.
sure.
So great looking core photos. In some, it looks like there's a massive amount of deformation in some of the strongly mineralized veins. Is there any indication from drilling on whether that deformation limits the vein continuity via pinching, etc.? PS, great work and exciting stuff.
That's a good question. So far, we're pretty early stage in really understanding the controls and the geometry of the controls. But it is possible. We do have holes where we thought we should hit and we didn't, and we have holes where we didn't think we were getting anything and we hit. So it's certainly a lot of structural complexity, and we've yet to figure out exactly what defines the geometry.
Okay, I guess I kind of had a follow-up. I was wondering if you guys had recognized any lithological controls like similar to what Tara presented in the Ormac zone. Have you guys noted anything like that?
Well, we're seeing mineralization kind of across the board there. We're in the Narchilla Formation, and we're in siltstones. We're in siltstones of the Sonoa member and the Arrowhead member, so two different members. And we're seeing mineralization at the contact, and that was kind of my working hypothesis going in. But we're seeing it very distinctly in both zones as well. We were initially looking for some kind of a rheological control, something like a sandstone or something to crackle up and to accommodate those fluids. But really, we're just seeing it in just pure siltstone. So it really seems to be, in the core photos, you saw a whole bunch of different textures and styles, and it really just seems to be finding its way into wherever it can, fold hinges, fractures, and that sort of a thing. So no real strong lithological controls that we can identify yet, but we're also really excited to see the Algae Lake Formation, which is a big carbonate unit. Shouldn't be too far below us there. So we're really curious to see what these fluids do when they hit that, both from a rheological and a chemical standpoint.
Awesome, yeah. If panelists, if anyone has questions or comments, just jump in. Kim, I think maybe you just heard about some mineralization in the Narchilla, which is your lateral equivalent of your vampire, I guess.
Yes, I did. I'm sorry that I missed Scott's talk earlier because I was interested and I read the press release earlier too. So, but I was too busy getting my own presentation scrabbled together in time. But I'll hopefully get to learn more about it. It sounds very exciting.
I guess a bit of a follow-up or maybe a bit of a segue, James or Tara. It looks like you're probably answering questions for Banyan, James. Greg Lynch asked the question at Ormac. Do you see any similarities to the mineralization at Ormac and Brewery Creek?
I don't know enough about Brewery Creek or the hosts of Brewery Creek, so I can't do that question any much justice, other than at Ormac, we have two styles of mineralization at Airstrip. It's compositionally controlled. We're seeing most of the gold mineralization lying within the calcareous units, the limey units. Then within Oryx Hill and Powerline, we're seeing gold mineralization within within quartz veins, not lithologically controlled at all. So I'm not sure what Brewery Creek gold is hosted in, if it's intrusion or if it's sediment hosted, but that's what ORMAC is.
Okay. I had a question about when Tara was giving her presentation, she mentioned that you guys had found Keno style veins in core.
Yeah, really waiting for those results.
Yeah, I reckon, man. Have you been able to pin any relationship, like timing, relative relationship between the gold mineralization and the Keno veins?
So our best cross-cutting relationship comes from when we were doing the airstrip drilling, which we focused in 2020 and prior to. When we're the Felsic dike, which has been age dated by Mortensen, I think it's unpublished, but it's around 93 or 94 million years old. We see this being cut by this when you have these beautiful vein blowouts, that's great, but a lot of the time what you see in these soft sourdough formation sediment rheological property rocks is just crackle breccia of anchorite, so siderite, manganese, iron carbonates, and you'll see that cutting through this dike. So that's our best age visible cross-cutting relationship for that style of mineralization.
Cool. Yeah, okay. Scott, there's one quick question here for you. I don't know where it comes from. Do you orient your core, and will you be doing so going forward? Great talk, great project. Can't hear you, Scott.
Yeah, thank you. It's, I guess, no and yes is the quick answer. We didn't orient this year. We are looking to orient next year and get a lot more information from each hole. We did do a set of downhole surveys at the end of the season to capture what information we could, but a lot of the holes had collapsed, and so it was kind of limited in terms of what we could recover.
Okay, thanks for that. Another question, this from David Moynihan. What's the thickness of the Sonoa member, and do you see any conglomerate, or is it all siltstone or sandstone?
So far, locally, we're only seeing siltstone. There's a really nice exposure nearby, just on the mountainside above Einerson Lake, where it looks to be, I would just have to hazard a guess at this point, but I would think it's between 100 and 200 meters thick, that order of magnitude. And I've walked it, but that was 10 years ago, and I couldn't tell you if there were conglomerates. I think it was mostly siltstone, though. I don't recall much until you get into the Algae Lake Formation, you start to get some big debris flow units.
Okay. Okay, I think I'm just checking to, okay, so Diane, there's a few questions in the chat for you. If I'll start with Gregory Lynch as a question. How thick do you think the tissue is in your map area?
Yeah, so I think it's about 300 to 400 meters thick. That's just looking at, like, it's fairly shallow dipping, you know, across the area, but looking at, yeah, all the elevation and everything like that, I think it's about 300 to 400 meters thick. So yeah, I'd be interested to talk with Greg just to compare what he's seeing in the Keno area. I hope that answers the question.
Okay. Another question, this one's from you, James, so you pipe up if I'm mischaracterizing it, but James is curious what those green bits were in your Highland, you says you strat column. I think you answered it during your talk, but maybe if you want to just expand or remind us.
Yeah, that's right. So those are some gabbro sills and relatively small intrusive bodies. So they're kind of not that common throughout the map area. I did kind of circle on my slide roughly where they are. They're mostly in the southeastern part of the area, or southeastern half, let's say, of the map. So they're hosted in the Eusebio and Norchilla formations, and they're gabbros that are sort of medium grained, CPX hornblende bearing. They tend to be quite, I think, discontinuous, at least at the surface. I think the biggest one I've mapped is about 150 meters across at the surface. And then I think chemically they're quite similar to the Paleozoic mafic rocks and in the Ogilvy Mountains and the Dempster Volcanics.
That's great. I was just tying it to, you know, where that thrust, the Robert Service thrust fault would come into in the McQuestion Valley area. And so we said in our talk that we have this observation and we see these gabbroic or these greenstone sills that they're in the tombstone strain belt. So they're deformed and they don't look like your rocks, but it sounds like if we do I think you had a chart on there that classified that separated the galena suite versus those gabbros and niobium, yttrium and something. So maybe if Patrick Sack wants to analyze that for us, you guys can figure out where to throw that thrust fault. or
How'd I end up in the middle of that?
Or you like coming to properties and analyzing things.
Yeah, I'll come visit for sure. Cool, but it seemed like from your plots, Diane, that geochemically they were fairly distinct. So maybe that's a first order exercise to just see what it says.
Yeah, that's right. I mean, all the galena suite, the Triassic galena suite sills, in general, I found they're quite a bit more. Well, first of all, they're in the urn group and the tissue, so younger rocks further south in my area, but they are a bit different from those gabbro bodies. They're quite a bit more continuous and mappable from ridge to ridge, whereas the gabbros tend to be, I think they're probably boudinaged or something like that, where they're a bit discontinuous. And geochemically, yeah, they are distinct from what we can see so far.
Okay. So Don Murphy left you a very open-ended question that you could probably go on for a while, I would imagine. Diane, well, nice talk, he says, but Diane, do you have any new ideas about what happened to the tombstone thrust?
Right. Yeah. So I didn't go over that in my talk because yeah, it is a bit of a something that I think we could discuss for a while. So basically the tombstone thrust had in this map area, it was previously traced in between basically in the urn group just north of the northernmost Triassic sills. So within urn group shales, and I did traverse along where that tombstone thrust would be expected based on the previous estimate of where it was, and I didn't find anything that showed that there was a distinct thrust there or anything that was sort of typical of tombstone related deformation elsewhere. So around the Keno area, from what I understand from Don's mapping and other mapping, it's characterized by westward or northwestward vergent kinematics. So everything I found in my area, that includes the area where the tombstone was traced and several kilometers on either side, was all north to northeast vergent structures, and kind of the foliation was parallel to the structural grain, which I think is associated more with the Robert Service or the Dawson than the tombstone. So for that reason, I left the tombstone off the map because I haven't found it yet. I guess one idea is that within the Robert Service thrust zone itself, there are some very locally some shear bands that dip downward towards the west. So there's been some discussion amongst at YGS anyway as to whether that might be an expression of the tombstone deformation, at least locally, maybe suggesting that there is some element of the tombstone strain zone that kind of coincides with the Robert Service thrust. But yeah, beyond that, I can't really say too much right now. I think maybe next summer I might have more to say about that because I'll be mapping a bit further to the southeast and kind of chasing where that tombstone strain zone might be.
Well done, all without a single diagram, because I know for myself, if I don't see a diagram of the tombstone thrust, I'm immediately lost.
Okay.
Thanks for that, Diane. I've got a question for you, Kim. You were talking quite a bit about vertical extent and sort of vertical potential on your property. I didn't catch how deep you've actually drilled to date so far.
225
or intercepted mineralization, I guess, is probably more interesting than just how deep you've drilled.
About 225 meters. and we're at a saddle, like most all deposits seem to be found. And we're also believe we're at an anticline. We're not sure where it is. It's going to be controlled by the cleavage, which is perpendicular to the foliage, the bedding, sorry. Down to 220 meters, that would put us elevation wise, we're drilling around 1,200 meters elevation. So down about, 1,500 meters elevation. So down about 1,250 meters elevation, mean sea level at the bottom.
So a vertical extent so far of something in the half-kilometer range, or?
No, 225 meters from surface is how deep we've drilled so far.
Yeah, and then you trace mineralization up on the hills, like on the flanks of your.
Oh yeah, sorry. Yes, there's
Yeah.
another 6. So we're at 1,800 meters at the top. So there's another 200-300 meters so vertical extent. Yeah, you're about nearly a kilometer, I would say.
Wow. Okay, so you've seen mineralization basically throughout.
That's absolutely right from the top. You saw that long section. So they're finding float up above that, close to 2,000 meters. That's float. So I can't really confirm that. I mean, rocks don't roll uphill, so it must have come from somewhere above. But yeah, there's you could almost easily a kilometer already that we know of, and it's open below us.
Okay, and again, I guess that same comment or question that I had for Scott and that James demonstrated so nicely on theirs. Do you see a lithological control? It sounds like you got pretty monotonous rocks.
Well, that's the thing we were looking for, the rheological contrast. I worked in Timmins for a long time, and the Timiskaming conglomerates are awesome, very brittle fractured rock. A lot of the gold in the Timmins camp is in that very brittle, shattered up conglomerate, flanked by sediments on one side and volcanics on the other. And that stuff is very tight and squeezed. It seemed, in my view, in looking at these type of deposits in the past, these fluids have a hard time getting through sediments of the type of slates and phyllites and gray wackies, as we call them in Timmins. That's a tough thing to squeeze through. Very, very soft, pliable, rock to get through. But when it cracks up, when those forces crack up against something like a conglomerate, I think you're in a sweet spot. I understand from Golden, from the 3 Aces, that seemed to be a bit of a stopper, and the gold was up against it. Now, I'm not the expert, and other people can comment on that, but there is that control, and that's why I was gunning for that. My comments that we knew about this quartz pebble conglomerate exposed on the outcrop on the road, and I've shown it to some of your colleagues. It doesn't exist on any government map anywhere. I'm inviting you out there, Patrick, to do some mapping and figure that one out, because what's that doing there? Is it it looks similar to what they see over on the other part? It's a very interesting thing to track down. And I said it disappears into the side of the hill. I was there for an afternoon, and I was trying to get to that soil anomaly, and I picked this up along the way. But that's what we want to find as a mark unit. I really don't have an understanding on the main zone where we are in the column. It's just this boring unit after repetitive altered slates that are now a phyllite type of thing, or whatever they might be, siltstones that they're converted over. And at the very far flanks of the property, you start seeing black shales, which they probably were before they got altered. So big, broad, thick alteration zone within here, and then finally gold at the very top of these axes. So I over-answered your question, but there's lots of stuff to discover there, and it's basic mapping and structural mapping, which I'm not, that's not my specialty. And we know that's one thing our property really could use, is somebody in there mapping, doing the detailed structural stuff and coming up with it's, because I believe strong at this point, structural control. But I don't see the lithological until we can find what's going on with one other marker rock type, like the quartz pebble conglomerate.
That's probably the only map I'm qualified to make, is a 1-unit map. I could come out and help you for sure with that.
Then it'd be really easy up at our place, because it'd be terrifying for you to come across the quartz pebble conglomerate where there's nothing but acres and acres and acres of phyllites. Yeah. But the structural stuff is fun to map. But I've done that work as well too, and you have to do a lot of compiling of it. But that's where the true understanding will be. And I'd said there's a couple of offsets. You look along strike. I said that new zone, the soil anomaly did. I'm looking along strike, assuming I'm going to follow a fold axis like forever. Of course, you're not. We do know we've got cross faults in there. Easily it kicked over to the east, where this new anomaly popped up in our work list last summer. So it's just so much fun getting into an early stage where not a lot of people know very much about it. I can make all the bad mistakes, bad interpretations at the beginning. Other people can shoot it down, but it's just fun being on there and following your nose for sure.
Cool. Well, that's awesome. We look forward to seeing you back next year.
Yeah.
I have one last question for you, Mr. Mike. Pretty curious about that Molly anomaly that Ryan highlighted towards the end of his talk. I guess one question, well, I'd like to know a bit more about it, but I'd also like, have you guys actually found molybdenite in outcrop and stuff out there?
Yeah, there was a sample that Ryan had, not this year, but the previous year, where in a brecciated granite found a little bit of molybdenite. Yeah, until we really started looking at the geochem, we didn't realize that moly was quite so extensive and associated with that silver train. You do see some propylitic alteration in there and lots of different indications. So it's, I mean, that's been the holy grail of the Mountain Skookum area, and now Bennett Lake is there a buried porphyry system somewhere in there? So that's an interesting kind of subset of data that came out that we threw in there to highlight that that potential exists. You know, so far all the mineralization is more typical of these polymetallic high-grade veins. But yeah, that's an interesting little teaser.
Mm-hmm. And what is it? Sorry, it was rocks like a grab sample anomaly. Was that what it was?
Yeah, most of those samples are float. It's all kind of talus in there, but it's an intersection of a number of east-west trending structures coming into that northeastern hinge zone. So where we do see those intersecting structures is where we see a bit better mineralization. Most of the rocks to date have been float and grab samples, but there's a number of areas where been able to chip sample actual veins and outcrop.
Cool, awesome. Yeah, great presentation by Ryan, as I said, and lovely to see. I'm out of questions that I tracked throughout this session. If anyone has a question that has not been asked, please do it immediately, or I'll give you maybe 20 or 30 seconds. And if nothing appears, we'll shut her down.
Yeah, Patrick, maybe I'll comment. There was the question for James on mineralization comparison to Brewery Creek.
Oh yeah,
I've
nice.
been both out to Banyan's property before it was Banyan's property, but also Brewery Creek. And Brewery Creek, the ore bodies are hosted in the quartz monzonite sills there. There are some showings that are hosted in the sedimentary rocks that have maybe a slight comparison to what Banyan is seeing, but not that same kind of extent where you've got that kind of nice replacement within some of the more calcareous unit and the quartz veining throughout the other kind of sedimentary rocks. So, in general, I think there's probably some underexplored areas of Brewery Creek that may end up looking like the McQuestion Oryx. But yeah, those ore bodies that have been mined at Brewery Creek are definitely hosted in those sills, and not similar to what they're seeing there quite yet.
Good, thanks for that, Mike. So thanks to all you presenters. That was a really informative session. Nice to see everyone's project seeing so much success, and nice background from you, Diane, on some of the stuff you're finding out there. I think that's it for the questions. I'll pass it back, I believe, to Brianne, and she can close us out.
Thank you to all our speakers today. And again, thank you to our partners, BMC Minerals and Yukon Government and YGS. Thank you to our sponsors, our silver sponsors, Smalls Expediting, SGS, Metallic Group of Companies, Tetra Tech, Sodexo, CSR Management, Whitehorse Gold Corp, as well as our copper sponsors, Banyan Gold, Minto Metals, Ivor, Kalani Drilling Ltd, Casino, Horizon Helicopters, and our nickel sponsors, Rockhaven Resources, SLR, North Country Consulting LP, up here, Yukon, and our zinc sponsors, Terrain Geoscience, Snowline Gold Corp, AMG, and again, our friends, Yukon Women in Mining and Great West Equipment. Please check out the Imagination Library and the Yukon Mines Legacy Foundation silent auction and join us for session 6 on Thursday, January 27th, where our theme is Yukon exploration and mining partnerships. We will have a live panel improving the alignment of the assessment and water licensing processes with Briony McIntyre from YCM and Pierce McDonald with the Yukon Water Board. Also a talk from Mika Leonard with Hummingbird Health, navigating workplace health surveillance programs. And finally, a chat with Yukon Government Economic Development Minister Ranj Pillai on advancing Yukon's exploration and mining ecosystem. Please register at yukongeoscience.ca, where all our sessions will be available for free viewing. Thanks again.